classes have like 30 odd students in them. I mean, it's still fine. It feels the same because we're remote. Uh-oh, did I finish? Worry about that. Let me see. It should be streaming. It seems like it is. Okay. Let me see. So I think for you all, I think I would rather try to make my way through some of the homework assignments. For the other groups, I've been making my way through the lectures, and you can honestly watch theirs. Get the student. It's the same material. If you want to go through the lecture, we can. But I think for you guys, I'd rather go through as many homework questions as we can. And so today, what I wanted to focus on was section 1.1, graphs of equations, and then on Wednesday we'll focus on section 1.2, lines. Now, this homework assignment was due last night at midnight. But again, with all of our assignments, you can work on any assignment past the due date. So let's take a moment. And if you'd rather go through the lecture, we can. But now, also, if you want to, I would encourage you to go back to my YouTube and like watch like my 3 o'clock, I think it's the same as you guys, or my 9 o'clock. I mean, a lot of the classes are the same. It's only one that's really different. But in those courses, in those classes today, what we did, I went through as much of the lecture. Now, the full lecture is actually available. So that's why I'm doing it a little bit different for you guys, since we have such an intimate group, a smaller group. I just wanted to try to get through as many homework questions as I can, unless you guys want me to go to specific questions. Oh, is it not working? Let me see. Customers can access and may experience error. Sign in again. In addition to create. Let me see. Let me try one more time. Maybe it's not working. It was working earlier. Allow.
Excuse me, I had a question, sir.
Go ahead.
So for purchasing the calculus math essentials, what should we do?
Say that again.
Because it's saying my math lab for pre-calculus essentials, first edition by Ratty. Yeah, is that the one we should be purchasing?
Okay, that's a good question. So let's actually go to the dashboard for Blackboard. Like when you log into Blackboard on the Morehouse portal,
yes, sir.
And like if we open up our course, which is this one, section 18. The landing page is here. So I'm going to open up this folder. And item number 4 are our assignments. So I'm going to click on that folder number 4. And you want to make use of the My Math Lab All Assignments, that first link. And so when you click on that link, that'll take you directly into our My Math Lab course. You want to purchase access to that. So the first item, My Math Lab, all it runs like, yeah. Let's see. It runs just under $120.
Okay.
But what this does, this gives you access. Additionally, because like going forward beyond this course, if you use the exact same book, Math Lab, you don't have to purchase access again. So I want to say I use this same book for 3 different courses. One called, and
I can access the account. It says I can access the link.
Yeah, it might be down right now. I tried to access it. Well, but now it's working. So
You're saying we're sorry, we haven't encountered an error.
Say that again.
It says we're sorry, we haven't encountered an error.
Yeah, just give it some time. Like I mean, let me try it because I'm. Just this real quick. For all assignments. And then when I click on the first one, right? So I'm able to access it. It might just be the login screen. I think if you like access to the Blackboard. All right, so I was, but yeah, I was able to get in through Blackboard. So when I accessed it through Blackboard, I was able to get in. I think it might be just their login screen that's creating an error. Trying to think of on you all's end, you might just have to wait it out because there's nothing that we can do about that right now. But so go ahead. So let me take some time. Go ahead. All right. Let me see. Okay. So let me take some time to go through as many of these questions as YouTube, but I think for you all, I wanted to try to get through some of the homework. So for instance, this one asks us to plot these points. So it says, for instance, 6, 4. So that means we go what, right 6 and up 4. So we should be in quadrant 1, which is this one, for part A. Which quadrant does 6, 4? That's quadrant 1. So the quadrants, quadrant 1 is the upper right, and then it goes counterclockwise. So quadrant 1 is the upper right, quadrant 2 is the upper left, quadrant 3 is the bottom left, quadrant 4 is the bottom right. So that point is in quadrant 1. So if we go to the right by 2 and up 0, that means we're on the x-axis, so it should be C. Okay. And that's on the x-axis. And then 4, -5 says to go right by 4 and then down 5. So that puts us into quadrant 4. So it should be C. And again, that's quadrant 4, which is this one. Okay. So when you go to work your own, it's going to be the same question with different numbers. And we're getting like partial credit because we're submitting this late. Find the distance between these and the coordinates of the midpoint. We need to write this one out. So hopefully you're taking notes like with the lecture notes. You just want to have a notebook that's neat and organized where you have a copy of the notes. And then as you work through the homework questions, you want to have a copy of each question with all the supporting details and your final answer in a box. So let me get a copy of this question. This comes from section 1.1. This is question number 5 from the back of this section. And we can cut it off like here. So then if we hop over here, I can take this and drop it right there. Okay. All right. So find the distance, right? So if you have a notebook, this is hopefully, you want to have a neat, organized notebook. And you have a section in your notebook where you are collecting formulas. You have a formula sheet. So every time you come across a formula, you definitely want to update that formula sheet. And there are 2 formulas here that you can update it with. The first one being the distance formula. So the distance between 2 points P and Q is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, in my presentations for like my 9 a.m. and my 3 p.m., I went through like where this context comes from, right? So like where this distance formula comes from, it comes out of the Pythagorean theorem. If you want to see that, just go back and watch the lecture that I did right before you guys. Okay. And then I'm also a fan, whenever I have ordered pairs, I like to just automatically label them as like x1, y1, x2, y2. All right. So that way it's much easier to just substitute them in the corresponding components in. So the distance between the points P and Q, square root. Now my x2 is 6. So I'm going to say 6 minus 6 squared plus 0 minus 2 squared. And I just plugged in the corresponding components into the formula. That's fine. Let me copy, paste. And on this one, let me get rid of this. Delete that. That looks good. Delete. Let me add a page. Okay. And if we keep going, the first term goes to 0. So you should be able to see that this guy here goes to 0. -2 times -2 is a positive 4. Square root of 4 is 2, right? So the distance between these 2 points is 2. Notice they both have the same x coordinate, and they only differ in y, and the y's are different by 2. The distance between those y values is 2. Let's see. Let's kind of do a few more. Okay. So that's the distance. I think it also asks for the midpoint. So another formula is the midpoint between 2 points. And the way I remember midpoint is your average of your x's, average of the y. So that's going to be x1 plus x2 over 2, comma, y1 plus y2 over 2. So midpoint between any 2 points is the average of your x's, average of the y's. So then the midpoint between P and Q here, let me see, is going to be 6 plus 6 over 2. Then I think it's 2 plus 0 over 2. So average of the x's, average of the y's. So I think that's 6, 1. So these are the coordinates of the midpoint of the point that's halfway between the 2 given points. Okay. So then what we want to do is take this back over to Pearson and see and check our results. Okay, so we got 2, 6, and 1. So the distance, let me see, the settings, on-screen keyboard, I want that off. I think we got a distance of 2. And then we got 6, 1. So I'm going to do double parentheses, 6, 1. Type in order pair, use integers or decimals for any number in the expression. Okay. Let me check the chat. So now, if anything is not clear, if you have questions, either feel free to unmute yourself or you can type your question in the chat. I do check the chat periodically. Yeah, okay. So this is an example. I know I had a student that contacted me over the weekend about this. Determine whether the 3 points are collinear. So what I'm going to do with this one, I'm going to show it 2 different ways. And first, I'm going to do the way that's a little bit more challenging for me, where basically you have to do the distance formula 3 times. And so you get like, we're going to get distance A, distance B, and distance C. And basically, if the sum of those 2 shorter distances equals the longer distance, then these 3 points have to be on the same line. Else they're not collinear, right? So let's start by getting a copy of this guy. So I think I'm gonna make it a little bit bigger. feel like this is good here. Then we're going to crop this like here. Okay, that looks good. Looks good. Okay. I'm including the question ID so that you know where this question is coming from. And we're going to drop it about here. Oh, this. That's good like that. Okay. All right. So determine whether, so again, we have at least two different ways of approaching this. So the first one, if the sum of the two shorter distances equals the longer distance, then we can say that they are collinear. Else they are not collinear. Again, collinear means co meaning the same or together, and linear meaning line. So are these on the same line? Are they together on the same line? Okay, so again, we're going to be using the distance formula. So again, one of my professors was like, every time you use a formula, write it down. So the distance between 2 points, x2 minus x1 squared plus y2 minus y1 squared. We're going to take the square root. Okay. Now in this one, I'm going to label, I'm going to say x1, y1, x2, y2, and I'm going to go ahead and do x3, y3. All right, because we have a third point. Those subscripts of 1, 2, and 3 means the first point, second point, third point. Okay. So I'm just going to label the first one as the first distance we're considering. So if we say x2 minus x1, that's going to be -3 minus 0 squared plus -16 minus a -7 squared. So you got to keep, you have to use your parentheses properly here. Otherwise, it's very easy to lose track. So then -3 times -3 is 9. Double negative there is positive. So I think that's going to be a -9 squared is going to be a positive 81. So I think that's the square root of 90. Okay, then the second distance, we did the first and second. So now let's do the first and the third. So that's going to be 2 minus 0 squared plus -1 minus a -7 squared. Okay. It's basically the same thing I did in the previous, just adjusting for the, you know, for the new points or whatever. Okay. So that first one gives us a 4. Let me see, double negative becomes a positive. So 7 minus 1 is 6. Squared is 36. So that's what, 40? Okay, and then the third distance. So we did 1 with 2, we did 1 with 3. So now we need to do 2 with 3. So we're going to say 2 minus -3 squared plus -1 minus a -16 squared. Okay. Let's add a page. And let's keep going. Double negative is positive, so that first one is going to be 25. 16 minus 1 is 15. 15 squared, I think, is 225. So then that's the square root of 250. So the thing we realized that we needed to do from earlier, we needed to find these approximations, right? So we're going to use our calculator and just go, okay, if we do the square root of 90 plus the square root of 40, let me see, 9, yeah, square root of 10. Let me see something. We might be able to get the
Can I ask a
exact.
question real quick?
Give me just a moment. I'm almost done with this one.
Okay.
So 90 is what, 9 times 10? So that's going to be, we can look at this one as 3 times the square root of 10, right? 4 times 10, so then that's going to be 2 times the square root of 10. 25 times 10, so that's going to be 5 times the square root of 10, right? So now, because we got all the same radical, now we can clearly see that indeed 3 times the square root of 10 plus 2 times the square root of 10 equals 5 times the square root of 10, right? So then now that we got the same radical, we can do it this way. And we can say that these are collinear. Let me go ahead and do the other version real quick. So this was using a distance formula. Let me do the equation of a line version technique real quick, and then we can entertain the question. So let me get a copy of this guy. Copy. And let me paste. Let me see how much. Let me get rid of this guy. Okay. So the way that I'm personally more comfortable using, now I know we haven't talked about this, but is y equals mx plus b, y equals mx plus b, the equation of a line. So I'm going to find the equation of the line through 2 points and then verify the third point. Now this first one already gave us the y-intercept. So it gave us that our b is -7. So then the third point just looks easier to use to me. So when y is -1, our slope, we don't know, but x is going to be 2. So we're going to have 2m minus 7. If I solve for m, we get 2m equals, what is that, 6? So then m equals 3. So then we get y equals 3x minus 7, right? So this is my claim for the equation of the line. So then we just want to verify that all 3 of these points work in this equation, right? So when x is 0, y is -7, so that one checks out. When x is 2, 3 times 2 is 6. 6 minus 7 is indeed -1. That one checks out. And then when x is -3, so 3 times -3 is -9. 9 plus 7 that's going to be -16. So this checks out as well. So we saw 2 different ways of verifying that these 3 points are collinear. Okay, there was a question. Go ahead with your question.
Oh, so for the first method, right? So once for first 2 distances equal the last distance, that means it's collinear.
Yeah, hang on. I had to reboot this thing. Give me just a moment. For the load. Let's see where to go. Did we lose the page or something? Okay. Right here, right? So we did the distance formula 3 times, right? And so yeah, if we say one short leg plus the other short leg, if it equals the long leg, like we did here, then we can say that the 3 points are collinear.
Okay. And can I see the second method again? Like the end of it, I didn't get to finish.
And then the second one, we use y equals mx plus b. Now they just happen to give us our y-intercept right here. Right. So when x was 0, y was -7. So I just took that straight from there. And then I plugged in this point. Thank you. I plugged in when x was 2, and y was -1, and our y-intercept was -7. So the only thing we didn't know was m, and we got this for m. Then we got this guy, and we verified that all 3 points worked.
Oh, okay. And then if all 3 points work, it's collinear too.
Yeah. So we found the equation of the line, and then we verified that all 3 points worked.
All right, thank you.
All right, so let's hop back to Pearson, and let's check our work. So we got a yes there. Come on. Yes, come on. Come on. There we go. Final check. All right, we got lucky. Okay. Chance favors the prepared mind. I'm tempted to do that first technique again. I know we're a little bit short on time, but I just want to just verify, just make sure that our logic is sound. I prefer to do the y equals mx plus b technique, but I'm also open to expanding. Let's go here. We'll drop it right here for the time being. And let me add a page. Pull this guy. Okay. All right. So let's try that first technique. Now again, you could do the y equals mx plus b. There's nothing wrong with that. I just want to try the distance formula again, just to make sure that it's working properly. So the distance between any 2 points is going to be the square root x2 minus x1 squared plus y2 minus y1 squared square root. Also, I'm a fan of labeling my points x1, y1, x2, y2, and in this case, I'm going to do x3, y3 because we have a third point. Okay. So my first distance, I'm just going to call it d1, is going to be what? -3 minus 0 squared plus -18 minus a -3. That one's a little bit nasty because of all the negatives, right? So then -3 times -3, that's going to be a 9. Let me see, double negative here becomes positive, so that becomes a -15. -15 times -15 is going to be what? Positive 225? Okay. So that would normally be 235, so 234. Okay. So then D2, so we did 1 and 2, let's do 1 and 3. So we're going to say 2 minus 0 squared plus 7 minus a -3 squared. And let's simplify. So that first one is going to be 4. 7 plus 3 is 10. So that's going to be plus 100. Square root of 104. Okay. Hey Siri, what's 234 divided by 4?
234 divided by 4 is 58.5.
Hey Siri, what's 234 divided by 2?
234 divided by 2 is 117.
Okay. So then for the third distance, let me see. So we need to do 2 and 3. So we're going to say 2 minus a -3 squared plus 7 minus a -18. Okay. So then that's a 5, so that becomes 25. Double negative is positive. Is that also 25 squared? Is 625? 650. So then I'm going to use my calculator. Hey Siri, what's the square root of 234?
The square root of 234 is approximately 15.297.
297, right? Hey Siri, what's the square root of 104?
The square root of 104 is approximately 10.198.
And then hey Siri, what's the square root of 650?
The square root of 650 is approximately 25.495.
Okay. So if we say This thing is totally, it just keeps throwing tantrums. Let me check the time. Okay, so the time is still good. I keep having to reboot for some reason. I'm not really sure. Just give me a moment. Oof. But you can see if you add those two shorter legs together, it equals the longer leg. Right? If we say the two shorter ones plus added together should equal the longer leg. So this one plus this one equals this one. So then are they collinear? We would say yes. I think they do. So let's go back here. So we got yes. So we're gonna go with yes. Okay. Let me check the chat really quickly. The chat looks good. Okay, let's keep going. We only got a few more minutes, so let's go to the next question. Maybe like right at about 10 minutes. Identify this triangle as isosceles, equilateral, a right triangle, or scalene. So this is another question on distance formula. Isosceles is a triangle where two of the sides have equal length. Equilateral means all three distances are the same or all three sides are the same. Right triangle is where, you know, the sum of the squares of the two shorter legs equals the square of the longer leg. So a squared plus b squared equals c squared. And scalene means all three. It's not a right triangle, and it's three sides of different length. Right. So this is another question on distance formula. So let me get a copy of this, and we basically have to find the distance between these. It's a pain, but you do it so much that it becomes second nature. You know, initially it is sort of a pain. And again, through the repetition, it becomes second nature. Let me drop this right here. And let me add a page. Come on. Right here. I don't know. Okay, that's fine. Okay. So we have to do the distance formula a few times, right? So let's start with the label. I usually like to go x1, y1, x2, y2, and because we have a third point, I'm just going to label it as x3, y3. Now the distance between any 2 points, x2 minus x1 squared plus y2 minus y1 squared. Okay. So we can do the distance between PQ. Let me see. That's going to be -9 minus -1. It's like they intentionally include all these negatives just to make it worse. Then we're going to say plus -3 minus a -3 squared. Okay. And then the square root of all of this. So double negative is positive. -9 plus 1 is -8. 8 times 8, that's going to be 64. I think that's 0. Square root of 64 is what, 8? So that's the distance that we got for PQ. Now let's go ahead and do PR. Okay. I can't shake this feeling. Like I was really glad to see, like in the latest Disney movie, Lightyear, there's a scene when he's like rocketing back to his planet. He's going at like warp speed. It's not full light speed. But he got off a trajectory, and if he doesn't course correct within time, he'll miss his mark and he'll like hurtle into space, and it'll be death for him, right? So he breaks out and does a quick calculation on his glass, and he does a quick, and I just liked it because it encouraged, like, oh crap, I actually had to use the bathroom, like save my life, right? that was kind of cool. But people use now, they don't necessarily do it like that, but there are people, like you have doctors and people, professionals that use this stuff. Not that you're gonna have to use it or anything like that, but if you're able to grasp these concepts, it'll give you an edge over your opponents or whatever, or over others. I mean, and again, I've had students that left, they go for a job interview, and the first thing they give them in the job interview is a math test, right? And it's about this very same stuff that we're talking about here. Okay, so for PR, another fun fact, I don't know if you ever watched the movie Hidden Figures with Taraji P. Henson, I think it was Taraji, and like Janelle Monáe and Octavia Spencer, I think is her name. But it's the movie where the women were basically calculators, right? They were doing the calculations for NASA, and so all those calculations that you saw was actually done by my colleague. He actually passed, but he was young, like he was like 50s, but he did all the calculations for that movie. And they did the filming at Morehouse, and I was in the classroom, and I would stop class. I would be like, "Okay, guys, just give us a moment." My wife was running back and forth in the rain, and they were making fake rain. It was so interesting. They brought in these like retro cars, and Taraji and another guy were running in fake rain outside of our class. So in all those scenes where she's running across campus in the rain, I'm actually in those scenes just off camera, like just above the camera. So, and we stopped class and we were watching them film. And that was a lot of fun. That was a lot of fun to do. But yeah, so my colleague Rudy Horn, he did all the calculations. So those calculations in there were accurate, and he's the one that did all of those. Yeah, it's not that you really need to know math, but when you know it, it gives you an edge. I really feel like mathematics is the language of a creator. Like people that are like building and making things, there are certain processes where it comes into play, and if you know it, it gives you an edge that you can actually take, use to your advantage. We're almost out of time. Let me see. So PR, let me see. So we're gonna say -5 minus a -1, right? We just got to keep track of those signs, and they're doing that intentionally to trip us up. And then we're gonna say 5 minus a -3 squared. Okay. So then here, double negative is positive. -5 plus 1 is -4, so that's going to be 16. Double negative is positive, so it's 8 squared is 64. Let's see, so that's 20, that's 80. Square root of 80. I think that's it. 64 is 74, 80. Okay. Let's see. 4 times 20. 4 times 5. So 16 times 5. 50 plus 30, yes, 16. So then 4 times the square root of 5. This is equal to 4 times the square root of 5. All right. I think that's okay. But we need to do one more. We did PQ. We did PR. We also need to do QR. Come on. Ugh. All right. I'll just go back and forth. So QR. Let me see. -5 minus -9. -5 minus a -9. Notice my use of parentheses. And then we got to say 5 minus a -3. Did I do that right? Yeah. 5 minus -3. Let's see. Double negative is positive. 9 minus 5 is what? 4. That's going to be 16. 8 squared is 64. Okay, this looks like it's isosceles, right? So it looks like we get our square root of 80 as well. right? And then that should be 4 times the square root of 5. So if we add those together, okay. So we know that the triangle is at least isosceles, right? Because 2 of the sides have the same length. So then we want to determine if it's a right triangle. So if it's a right triangle, it should be the case that a squared plus b squared equals c squared. So if we say 4 times the square root of 5 squared plus 4 root 5 squared, 16 times 5, I think that's going to be what? 80 plus 80 is 160. Nope, which is not equal to 64, right? So it's not the case that a squared plus b squared equals c squared. So it's not a right triangle. It's not a right isosceles triangle. We get that it's just isosceles, right? We get that it's isosceles because 2 of the sides have the same length. Okay. So let's see, how do we do? Let's submit this one, and then we're going to call it a day. Oh, please don't refresh. Thank you. Okay, so we got isosceles, check. Is it a right triangle? We said no, because it does not satisfy a squared plus b squared equal to c squared. Okay. All right. So, we made our way through several questions. Did you guys have any questions for me before we go our separate ways? So let me encourage you to go ahead.
Excuse me, sir?
Yeah.
I had a question on the homework that we had last night, or was it last night, or was it 2 days ago?
Uh-huh.
It was 2 days ago?
It was last night, but it's the same. Go ahead.
Oh, I had never gotten the notification that we had an assignment due at any time. So because I can't access my Pearson account, it's not letting me.
Yeah, I'm having the same problem too.
Yeah, like, okay. So with all of our assignments, we get unlimited attempts. You can work on it past the due date. So like you can still earn a 90 on it. A 90, like the homework is only 10% of your grade and the quiz is only 10%. So at most it's like 1% of your overall grade, like a point for that late penalty. It's a very small late penalty. So just I would just encourage you to just keep working to gain access. And then once you get access, just try to maximize your points.
All right.
Because it's right now, it's not really going to affect you. It's not
Is
big.
My fault,
But
sir.
it's no worries. But you just want to get up to speed as quickly as possible because you want to try to maximize your score in your exam. All of this is just in preparation for your exam. And there aren't any notifications for like assignments. It's just that every week you have like for instance, this week we're really supposed to be working on section 1.2. It's every week our assignments are due Sundays at 11:59 p.m. So, but again, you can work on it past the due date with only a 10% late penalty. Unlimited attempts, and it's gonna take your highest score. So just kind of do the best you can with last week. Try to get in there and go ahead and submit the assignment for this week, and you can go back and work on last week. And as long as you get up to speed by the time of the exam, because the exam is where it really counts. For the homework and quizzes, that's really just practice to get ready.
So how far? Sorry to interrupt, sir, but how far? So since I didn't finish that assignment last night, how far back am I? Am I a week or am I?
It's only one assignment. It's one assignment per week.
Okay, so I'm just one assignment away from catching up.
Yeah, one
and
homework.
I can go ahead of the class, correct?
Yeah, you can get ahead. All the lectures are available for the entire semester. The homework is available. The quizzes are available. The only thing that's not available are the exams.
The tests.
Yeah.
Right, because I have to meet the requirements before I take the exams, correct?
Well, I don't release them until like week 4.
Okay. I got you.
The final, yeah.
Okay, thank you.
Yep, go ahead. There was also another question.
Yeah. Oh, my bad.
You good?
Okay, so I'll go then. So you think like the school could like help me like login, or it's just like a thing
It's
within?
more of a Pearson thing, because when I went on there, they were even saying that they're having issues. It's more of a Pearson thing. Just keep trying to log in. It might take like a day or two. They're usually pretty good about resolving these things. It's nothing that Morehouse can do. Have you already purchased access? If you're still trying to purchase access, as long as you have the funds ready to go, you have to keep working with Pearson. That's something with Pearson. That's not Morehouse. It's not any of us. That's a Pearson issue.
Okay.
So you just have to keep trying until it gets in. You're able to get in.
Okay. Thank you.
Any other burning questions before we part ways? So, this session was streamed live on my YouTube. I would encourage you to maybe check out, some of the things I said with my other classes, because all except my 1 p.m., we all go through the same material, but I kind of do different stuff. So like with them, with the other groups, I think I did like the lectures. I went through as much of the lecture. So that's why I decided to do something different with you all, because I know that you all can access each other's sessions. So if there aren't any other burning questions, we're going to end the session here. We'll meet back Wednesday, same time, same place. And from one beautiful mind to another, enjoy the rest of your day, guys. Take care. Peace.
Have a great day.
You too.
Have a nice day.
You as well.